and the N64 version. All right, here we go. All right, look, let's get back into this because I'm recording this for all you guys that are going to go take pictures and be absent. But guess what? Yeah. This is the Bohr model of the atom. It doesn't really look like this. What you're about to learn is what these letters mean. S, P, D, F. Okay? I want you to go to page 154. We're going to look at pictures of what electrons actually do. Okay? And on page 154, also in Google Classroom, I want you to have both open. Okay? So you have Google Classroom and page 154. I want you to click on this thing that says Orbital Shapes. Orbital Shapes. And they make these weird shapes. Okay? Now, right, are you on the Google Classroom part? Did you click on the thing that says Orbital Shapes? And you got these weird looking shapes. Well, what are these? If you notice, they have letters on them. What letters do they have? S. What else do they have? P. What else do they have? D. What else do they have? F. Did we just draw those letters? Okay, now, the letter S means that electrons fly around and they make this circular shape. So it doesn't look like a ring. It means if it's an S sublevel, the electrons are zooming around at about the speed of light and they're making this shape. So what you do is you take your pencil and you make a bunch of little dots in there, and it would make the shape of a sphere. That means the electron is flying around making that shape. It's not an actual ball. Okay, it's not a ball. It's just that's where the electron is, and it flies around and kind of makes that shape. Now, Ruben, I think you know, how are we supposed to know this? Well, the answer is calculus and computers. Okay? That's how. All those guys, Heisenberg, de Broglie, Schrodinger, they were masters at math. How many of you are taking pre-calculus right now? Anybody? No? Next semester? Okay, so they were masters at supercalculus. And that's how they came up with this stuff. Well, if it's a P, there's 3 possible flight patterns or shapes that an electron can make. It can go like this. It can make a dumbbell this way. You see how they're dumbbell shaped? Or potato shaped or egg shaped? Maybe like a couple of eggs. Right, Keon? They could fly around like this, like this, like this, and like this. And I'll bet you're wondering, what in the heck is XYZ? What is that, Ruben? Well, I'll tell you. You ever made a graph in math class? Okay. You ever in math class seen an X and a Y axis? You ever seen that? Does the real world actually have an X and a Y axis? No, it has 3 dimensions. We live in a 3-dimensional universe. Everything has a length, a width, and a height, right? Okay, so what you do is you draw a Z line right through them. 3-dimensional graph. You guys have never seen that before. X, Y, and Z are 3 dimensions. Length, width, and height. Okay? So, the electrons make these shapes. They fly around. So a P means they're going to make these P shapes. And it gets even more complicated. If there's a D letter, it means it makes these shapes. Right? So you got to have more and more electrons to make more and more of these shapes. Look at this. Look at all these F shapes. They're weird. I do not expect you to be able to draw any of this. That's way too complicated. Here's what I do expect you to know. How many shapes, if you see the letter S, how many shapes do you see? How many different shapes do you see? 1. How many P shapes do you see? No, you don't see 2. You see 3. I see P, P, and P. Okay, how many different D sublevels do you see? 5. And how many F sublevels do you see? 7. Now check this out. In each little sublevel, you can hold 2 electrons. What's 3 times 2? Or 3 times, I'm sorry, my bad, I jumped ahead. What's 2 times 1? Okay, so 1 times 2 equals 2. All right, let's erase this guy. Erase this crap. Tell me what 3 times 2, we got 2 electrons. 1, 2, 3, 4, 5, 6. What's 3 times 2? 6. In each one of these, you got 2. Okay, so what's 5 times 2? Okay, 5 times 2 equals 10. And 7 times 2 equals 14. Okay. So every time you see a letter S, you have one type of shape that can hold 2 electrons. Every time you see the letter P, 3 different shapes times 2 electrons. Every time you see a D, 5 different shapes times 2 electrons, and F is 7 shapes. Now, do you all understand what I mean by shapes? Somebody explain it back to me. David, explain to me what makes these shapes. They move really fast. They just fly around. Okay? You ever seen a bird fly around? Okay? You ever seen a honeybee or a mosquito fly around? Wouldn't it be cool if you could like 3D track a mosquito and see what kind of flight pattern it makes? Or the birds? Like, what would it look like if birds had a vapor trail? What would it look like in the sky? If you follow them? Okay? All right. So you have to know that those letters mean shapes. Now, one more time. Tell me what Heisenberg said. Hector, what did Heisenberg say? Can't find the exact location of the electron. Josian? Heisenberg said what again? And Milliron's Heisenberg said. And Sean Heisenberg said. Okay. Do you want to know what de Broglie and Schrodinger and Max Planck said? You can guess. You can guess. So what I'm going to teach you today is how to guess where the electrons are. Don't worry, we're not using any calculus. No math. No math. Just periodic table, okay, and these shapes. And we're going to guess where the electrons go. It's going to be close. We just can't ever be exact. That's why we can't ever beam somebody from here to over there. Y'all ever hear that show Star Trek? Okay, in Star Trek, you could beam somebody from here to like over there, like teleport them. You can't really do that, Hector, because if you do that, you destroy the person and then reassemble them over there. So, and if you don't know exactly where their electrons are, you can't put them back together. Like you would just be a blob. All right, now, yes, ma'am. Yes, if you need to go take pictures, take pictures. That's why I'm recording this stuff for you guys. Okay, here we go. I want you to go back to Google Classroom, and now I want you to click on this thing that says Hog Hotel Orbitals, and we're going to learn how to put electrons where they're supposed to go. And how many of you have ever been on a farm? Sunday, a farm is a place where they have animals and crops and wheat and tobacco and tractors and hay and cows. Sometimes they don't have cows. And sometimes pigs. Okay? A farm is how you get to go to Shoney's and have the buffet. It might be disgusting, but it's pretty cheap. It's like $7. That's where all the old people go. All right, IHOP. Sunday, a farm is how you can have IHOP. Okay? So click on this thing that says Hog Hilton. And we're going to learn about pigs on a farm, and that's going to teach us about where electrons are. Literally. We're going to learn about pigs on a farm, and pigs will teach us about how to find electrons. I'm serious. Okay? So click on this thing that says Hog Hilton. All right, and Miriam is going to read us that paragraph about hogs. The Hog Hotel, the Hog Hilton. Go ahead, Miriam. You are. Yes. Hmm. All right. Rule number one, Miriam. Hogs are lazy. Rule number two. Hogs can't stand each other except when rule one forces them to put up with each other. Okay? If you were a hog, you probably couldn't stand another hog either, right? They're disgusting. Like how disgusting? Well, can hogs eat dead bodies? Yes. Number three, if hogs are in the same room, they will face in opposite directions. And Sunday, rule number four, no more than two hogs in a room. So here's how we're going to do this. Okay? A hog, what do y'all think of my hog here? I'm going to draw a hog. This is from the top down. What do you think of that? Is that a good hog? Okay? So this hog is going to face that direction. And then, okay, this hog is going to face that direction. Well, why do they do that? Because they're disgusting. They're hogs, right? This hog, Miriam, will face this direction. Okay, Miriam, everything I'm doing up here has a purpose. You might want to look. So if you put a hog in a room, you just simply put it like this. Okay, this one faces up, and the next one plops down. Instead of having to draw a hog every time. Okay? So now you and I are going to put hogs in a room. What I want you to do in your little notebook there is I want you to copy this hotel exactly the way it's done. I want you to put first floor, second floor, third floor has 3 rooms, fourth floor has 1, fifth floor has 3 rooms, sixth floor has 5 rooms. That looks kind of vaguely familiar. 135. 135. Where have we seen 135 before? The shapes? Oh my God, you're exactly right. Are you saying we're learning about the shapes? We are? Oh, wow. So we're going to put 15 hogs in their rooms. Okay, using our rules. Using our rules. Miriam, where's the first hog go? On the first floor, right? Yeah, so we're going to put it up like this. Right, where does the second hog go? You use your rules. Does it going to walk up to the second floor or plop right down on the first? Yeah, it's going to plop on the first. Why Sunday does it do that? Hogs are lazy. Okay, they're lazy. Hello. Yeah. Mm-hmm. Mm-hmm. At the end of class. All right, second hog. We got to put 15 hogs in here. Where's the second one go? Jacob, where's the second one go? It goes up the stairs. You can't put more than 2 hogs in a room. Where does the third hog go, or the next hog go? Yep, plop. Okay, now on the third floor, it gets different Sunday. Okay? A hog's going to go here, right? Where's the next hog go? No. Hogs hate each other. Now there's 3 beds in the room, or 3 rooms on the floor, rather, whatever. Is the hog going to be by itself if it's allowed to be? Hog. Where's the other hog go? Okay. Hog. Where does the other one go? Oh, well, please explain why it's going to plop. Well, why doesn't it go to the fourth floor? Because it's farther, and hogs are lazy. So give them the choice Sunday between smelling another hog or walking up steps. It's going to smell another hog. So it's just going to plop, plop, plop. Okay, we got 2, 4, 6, 8, 10. And then we go 11, 12, 13, 14, 15. Now, what is the purpose of us learning this, Sean? Just to be stupid? No, what is the purpose? We are actually learning about what? The electron clouds, the electron orbitals. Yes, the shapes. Okay, so Akime, does this 1, 3, and 5 sound familiar to you? Okay. Now, how many pigs are in each one? In each little space, how many pigs are there? 2. Now, that changes 1, 3, and 5 into 2, 6, and 10, doesn't it? Yeah. Okay. All right, now we're going to put 25 hogs in the room. Now we're going to do this one. We're going to do this one now. Okay, let's go faster, Tony. Ready? Okay. Up, then what? Down. Then what? Up, then down. Then, yep, then, down. Good. So we keep going with this pattern all the way until we get to 25, right? Let's see. 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Double check me, make sure I've got 25 there or something. All right, Ikime, like I said, okay? Look. 1 bed, 1 bed, 3 beds, 1 bed, 3 beds, 5 beds. We seen those before? 1, 3s, and 5s? Where did we see them? The shapes. How many electrons can go in each one of those shapes? 2. Well, let's do some math here. What's 1 times 2? 2. What's 1 times 2? 2. What's 3 times 2? 6. What's 1 times 2? 2. What's 3 times 2? What's 5 times 2? 10. Now, are you all understanding the hog rules and how to put them there? Ruben? Jeremy, questions? Jackson and Ruben, no questions? Okay, you good on why the pigs get their own rooms? You good on why they plop down? How many pigs can go in a space? 2. Okay, guys. Now gets more complicated, okay? The the shape of the pig hotel. I want you to flip to this page, scroll down. I want you to copy this into your notebook. Hey, it's got the letters on there. What are those letters from? What are those letters from? Where have we seen those before? S. The orbital thingies. The Bohr model energy. The orbital things. But I want you to copy this shape. On the last page, you learn how to fill up an imaginary hotel. Now you will relate this to the example of electron orbitals. Electron orbitals are modeled by the picture below and grouped into principal energy levels. Okay? Yeah, you copy that. That shape right there, the way it's drawn. The way it's drawn. Okay? So you see, look at those orbital shapes. You have S's, you have P's, you have D's, you have F's, right? Well, right here, got the same thing. Same thing. Okay. Well, why is it shaped like that? Every time you see the letter S, how many shapes did we have? We had 1 shape, Tony. That's why we have how many spaces every time you see an S? 1. How many shapes every time you saw a letter P did you see? 3 shapes. Well, how many beds are in the letter P? 3. Every time you saw a letter D, how many shapes did you see, Sean? On the pictures. When we looked at the picture. 5. 5. Okay, we saw 5. 5 of these little D shapes. So if we look on this Hog Hilton, how many beds are on the D shape? 5. 5 spaces. Okay, now F would have how many spaces? 7. All right? Good job, folks. Good. Good. Okay? So, let's do this. Okay? On your little thing you just drew, we're going to put in 16 electrons, okay? 16. Let's do 16. Let's jump right to it. Here we go. Zoom in some. 16 electrons. Ready? First one goes up. First one goes up. Where does the next one go? Down. Okay? The next one goes up. Where does the next one go? Down. The next ones go where? Up, up, up. Up, up, up. And the next ones go down, down, down. Okay? All right. Where's the next ones go, Jacob? I need 16 total. Up, and then down. So I have 2, 4, 6, 8, 10, 12. Up, up, up. And one more down. My man. Now what I'm going to do, guys, is I'm going to write a summary. Okay? I'm going to write a summary of this. Watch this. Watch this, folks. In room number 1S, how many hogs do I have? So I'm going to put a superscript 2. Superscript means Superman goes up in the air. Submarines, subscripts go down, superscripts go up. Okay? In room 2S, how many hogs do I have? So I'm going to put a little superscript 2. Okay? In room 2P, how many hogs do I have total? 6. I'm going to put a little 6. In room 3S, I have 2. In room 3P, I have a total of 4. Who can tell me what 2 plus 2 plus 6 plus 2 plus 4 equals? 16 hogs. You add up all the little purple numbers. 16 electrons. 16 hogs. See that? Okay, so what did we just do? What did we just write? Who cares? What is the point of us learning this? The point is that we just guessed where the electrons are. Yeah, so in sublevel 1s, how many electrons are there? 2. In sublevel 2s, there are 2. At 2p, there are 6 pigs. In 3s, there are 2 pigs, and in 3p, there are 4 pigs. So if I were to draw my Bohr model atom again, that's where I would put my dots. That's where I'd put my little electrons. Right. So if I had my little atom here, okay, actually I would have 16 protons, whatever. But in my first ring, I know I would have 1, 2 electrons. Okay? In my second energy level, okay, because I would shoot. I wanted this. What? I had 2s and I had 2p, right? I know I would have 2 electrons here in 2s, and I would have 6 in p. 1, 2, 3, 4, 5, 6. Okay? And so on. Oh, yeah. Did we just guess where our electrons are? We did. Now we can't draw. I can't, guys, I can't draw that. High school students can't draw that. I can't draw it either, Sean. So you know what you teach high school students? You teach them with the Bohr model of the atom. All right, that's how you teach high school students electrons. Okay, so we still use the Bohr model atom to teach chemistry. You awake over there, Monday? All right. Okay? All right, now. Everybody go to back to Google Classroom, and this will make even more sense. I'm going to make this even simpler for you guys. Go back to Google Classroom. Here we go. Erase all that. Come on, internets. The internets. Go back here and click on this thing that says periodic table info, guys. Click on that, Jackson. Do you see any letters, S's and D's and P's and F's? Do you see them? Well, you don't see the F's. That was because the S would be down here. F1, F2, F3, F4, F5, F6, F7, F8, F9, F10, F11, F12, F13, F14. Okay? All right. How many columns have S's? No? 2 columns. This S2 right over here is just for helium. And the reason why is because helium is too small to have more than 2 electrons. Okay? How many columns do you see for the letter D? 10 total, Reuben. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many columns do you see for the letter P? No, you see 6. 1, 2, 3, 4, 5, 6. Double gases. And how many columns do you see for the letter F? 14. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Where on earth did they get those numbers from? Duh, I just don't know where they got those numbers. Hey, could it be from the shapes? Yeah. Okay, so y'all connecting now? Yes? Okay. All right. What I'm going to do now is I'm going to teach you how to do this without having to memorize. The only thing you have to memorize is that the first 2 columns in the periodic table get the letter S. Anywhere in these, get the letter D. And anywhere in here, get the letter P. I'm going to teach you how to do the Hog Hilton without having to memorize what the thing looks like, the hotel. How many of you know what a motel is? What's the difference between a hotel and a motel? Okay, size, cheaper, what else? What about the outside? The door outside, yes, the door opens to the outside. That is correct. Well, let's look at the difference between a hotel and a motel. Here we go. A hotel builds upwards. Okay? What does a motel look like? Sideways. Yes. Okay, a motel goes sideways. See? And it's cheaper, and it's, you know, sketchy. Right, Reuben? A clown motel. What the breaks? A creepy clown motel. Oh, Lord. Clown motel. Okay. So now have this up on your screen and have a periodic table ready. Here's what we are going to do now. Who's Homer Simpson? Who's that? Yeah, that's cool, Jackson. I like that. Yeah. All right, class. So what we're going to do now is we are going to figure out where the electrons go in which orbital. Okay, we're going to figure out all the hogs to the element hydrogen. Okay? So you're going to go to a blank page now in your notebook, and we're going to write all of the, we're going to write all of them up to, say, let's go all the way to, we're going to go all the way to SC. Now, it's going to be easier than you guys think. All right, where's your pencil? Where's your notebook? Where's your periodic table? Where's blank page? No, that's this. Where's the regular periodic table? Okay, you need a regular periodic table, you need this screen, and you need a pencil with a blank page and notebook. Okay, guys, we are going to get, this is called electron configuration, meaning, Sunday, we're going to put the hogs in the orbitals. We're going to put the pigs where they're supposed to go. Okay? Here we go. Okay, hydrogen. Hydrogen. Put the hydrogen on the regular periodic, the real periodic table. Okay, the real periodic table, point to hydrogen. Turn it right side up. Okay, what row is hydrogen in on the periodic table? S. So I want you to put row 1. And what letter orbital does it have? Does it have any P's? Does it have any D's? Does it have any F's? Does it have an S? S. Okay, now how many spaces have you gone? To the first space. 1. There it is. You didn't have to draw any pigs. Let's go to helium. What row in the periodic table is helium in? It's in row 1. Rows go this way, guys. They go across. Okay. Look on that screen. Look on your screen and tell me what letter of orbital it has. It has an S. Does it have any P's? Does it have any D's? Does it have any F's? No, it has an S. How many electrons go in that S orbital? 2 of them. That's the answer. Okay, now everybody go find lithium on the periodic table. Lithium. Lithium. Not L-E-G's. L-I. Lithium. Now, how many total electrons does lithium have? 3, Ruben. It has 3 total electrons because it's element number 3, right? Well, guess what? It has all of this stuff, too. It has all the electrons that helium has, and then it has 1 more. So, yes, it has this stuff, but it's also in row 2. Okay? And what letter does it fall on? Look at your screen. What column is it? S what? 1. It has a total of 3 electrons. Look, 2 plus 1 is 3. That's right. Okay, what's the next element? Beryllium, Be. Is anybody noticing a pattern here? Okay? Be, it's in row 2. Well, it still has all this stuff, except it has 1 more electron. So it wouldn't be 2s1, it would be 2s2. Two S2. Jackson, you noticing a pattern, my man? Not yet. Not quite. Okay, go to boron. Be boron. Put your finger on boron. Boron has all of this stuff, because we're just adding on electrons. It's got all this stuff, but now it's in row 2, and what section in the periodic table is? Looking at your screen, what letters should it get? What letter orbitals? P. All right, what column does it say? P1. Oh, looky there. 2 plus 2 plus 1 is 5 electrons. It has 5 electrons. It's atomic number 5. Nobody's noticing a pattern yet? Carbon. Jackson, what's the pattern, man? All we're doing is adding on how many more electrons? 1 more electron each time we go. Carbon has everything the same, has all this stuff, but instead of 2p1, it's 2p2. Yay, David. Está bien. Okay? Miriam, Mariah, nitrogen. What do you think nitrogen would be? Everything the same, except the end is, you say 3? 2p3? 2p3 is correct. Riding Hood get her basket stolen? No, she didn't. Oh, she did. Oxygen. Okay, what would it be? 1s2, 2s2, 2p4. Very good. Fluorine. Quickly, what is it? 1s2, 2s2, 2p5. Smart kids. And neon. What would it be? 1s2, 2s2, 2p6. That's the furthest one you can do. Okay?